Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P1129, indicates a problem with the manifold absolute pressure, MAP sensor signal in the Honda Civic models from 2011 to 2015. Specifically, this code suggests that the MAP sensor is providing a signal that is higher than expected, which can lead to various performance issues in the vehicle. The MAP sensor is crucial for measuring the air pressure inside the intake manifold, which helps the engine control unit, ECU, determine the right amount of fuel and air mixture for optimal combustion. A malfunctioning MAP sensor could cause poor engine performance, increased emissions, and potentially damage other components if not diagnosed and repaired promptly. Effective troubleshooting of this error will require a systematic approach, including checking for vacuum leaks, assessing the performance of the MAP sensor, and verifying the problem through multiple tests. The DTC P1129 refers specifically to the MAP sensor, an important component that measures the air pressure in the intake manifold of your Honda Civic. Its primary role is to send data to the engine control unit, ECU, allowing it to adjust the fuel-to-air mixture for optimal engine performance and efficiency. The MAP sensor is usually located directly on or near the intake manifold, where it can accurately gauge the air pressure. If the MAP sensor detects a level of pressure significantly higher than expected, indicated by this DTC, it can trigger the check engine light as a warning. Components that may also be involved include the positive crankcase ventilation, PCV valve, PCV hose, evaporative evap canister purge valve, throttle body, and the brake booster. As leaks in these areas can affect sensor readings, it is vital to address this error quickly to maintain overall vehicle performance and functionality. The possible causes of DTC P1129 include vacuum leaks in critical components, a faulty MAP sensor, poor electrical connections, and intermittent sensor failures. Vacuum leaks may occur in parts such as the PCV valve, throttle body, or brake booster hose, leading to unexpected pressure readings from the MAP sensor. A faulty MAP sensor itself could provide erroneous high readings, resulting in the DTC being triggered. Additionally, poor electrical connections to the MAP sensor or the engine control module, ECM, can result in signal issues, contributing to the error. Intermittent sensor failures may also play a role, where the MAP sensor occasionally provides invalid data, complicating diagnostics. Proper identification of these issues is essential to effectively rectify the underlying problem, causing the DTC. The symptoms associated with DTC P1129 typically involve activation of the check engine light, indicating that the vehicle's onboard diagnostics have detected an anomaly. Drivers may also experience poor engine performance, characterized by sluggish acceleration and reduced power. Another common symptom is increased fuel consumption, as the ECU may struggle to maintain the proper air-fuel balance due to the faulty MAP sensor indications. Additionally, rough idling can occur, where the engine may shake or struggle to maintain a consistent RPM at idle. Recognizing these symptoms is crucial for drivers to understand when to seek further diagnostic testing and potential repairs. The first step in troubleshooting DTC P1129 is to check for vacuum leaks in several critical components of the engine. Common areas to inspect include the PCV valve, which helps regulate pressure in the engine, the throttle body that controls air intake, and the brake booster, which can affect the accuracy of pressure readings. Inspect the hoses and connections for signs of wear or disconnection. If a vacuum leak is identified, it is important to repair or replace the affected parts before proceeding with further steps. Failure to address these leaks may lead to incorrect readings by the MAP sensor and ongoing issues with the vehicle's performance. The second step involves performing a performance check of the map sensor. Begin by starting the engine and holding the RPM at 3000 without load until the radiator fan engages, after which allow the engine to idle. This step is crucial as it puts the engine under conditions that may reveal the sensor's performance capabilities. Using the Honda Diagnostic System, HDS, monitor the map sensor readings in the data list. Verify if the reading exceeds limits of 36.9 kilopascals, 11.0 inches of mercury, or 277 millimeters of mercury, or 1.1 volts for more than 5 seconds. If the HDS returns a yes response, it indicates that the map sensor is indeed faulty and needs replacement before verification steps can occur. In the third step, clear the DTC using the HDS, allowing the onboard computer to reset and eliminate any stored error codes. Following this, conduct a test drive under specific conditions. The engine coolant temperature must exceed 158 degrees Fahrenheit, 70 degrees Celsius, and the engine speed should be held between 1400 and 6800 RPM in the fifth transmission gear. During the drive, maintain a steady speed between 55 and 75 miles per hour, 88 to 120 kilometers per hour, for 10 seconds before decelerating with the throttle fully closed for another 5 seconds. After completing this drive, monitor the OBD status for DTC P1129. If the HDS indicates a failed status, this confirms that the failure has been replicated and the map sensor requires replacement. The final troubleshooting step requires you to perform repair verification to ensure that the issue has been resolved. First, turn the ignition switch to the on position, II, and utilize the HDS to reset the engine control module ECM settings. An essential part of this process is to perform the ECM idle learn procedure, which adjusts the engine settings for optimal idle performance. After resetting, start the engine again, and once more, hold the RPM at 3000 without load until the radiator fan activates. Following this, repeat the test drive conditions described in the previous step. Finally, monitor the OBD status for DTC P1129. A past indication means that troubleshooting is complete, while a failed response necessitates revisiting prior steps for thorough checks. Final repair verification is critical to ensure that the repairs made during the troubleshooting process have resolved the issue with the map sensor. After completing all necessary repairs, monitor the onboard diagnostics (OBD) status to confirm that the DTC P1129 is cleared. Additionally, ensure there are no other pending or confirmed DTCs that could indicate leftover issues. This verification process not only reassures the technician of a successful repair, but also provides the driver with confidence that their vehicle is operating correctly. If the DTC has been cleared without reappearing during subsequent tests, the repairs can be deemed successful. Preventive maintenance is essential in ensuring that issues like DTC P1129 do not recur. Routine checks for vacuum integrity can help identify leaks before they cause significant problems with engine performance. Regular inspections of the map sensor and its connections can aid in early detection of faults, minimizing downtime and repair costs. It is also beneficial to monitor engine performance regularly. Any decline can be a precursor to underlying issues such as a malfunctioning map sensor. Establishing a consistent inspection routine fosters vehicle reliability and extends the lifespan of components, leading to better overall efficiency and performance. In conclusion, DTC P1129 signifies a higher than expected signal from the map sensor. pointing toward potential vacuum leaks, faulty components, or poor connections. The structured troubleshooting process laid out includes necessary checks for vacuum integrity, thorough performance assessments of the MAP sensor, and reassurance through repair verification. Each step is crucial in diagnosing the issue accurately, ensuring that an effective resolution is reached. Furthermore, implementing preventive maintenance measures can significantly bolster the reliability of the vehicle, reducing the likelihood of recurring DTCs. Understanding the implications of this trouble code helps drivers and technicians work collaboratively towards maintaining optimal vehicle performance. Please like and subscribe to the channel. See you next time.